Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Discover why many of the world's largest organizations innovate securely with Invicti. Visit securityweekly.com/Invicti. The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, improve compliance and audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Welcome back to Application Security Weekly. We just talked with Akira Brand about secure coding, code reviews, and being an effective educator. Not to mention it has some fun visual novels to be looking forward to about AppSec training. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. But first, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. Plus, do you have a specific guest or a topic that you want us to cover on one of the shows? Submit your suggestions at securityweekly.com/guests. We review suggestions monthly, and we'll reach out to you once reviewed. Mr. Kinsella, back to you and me. And ASW is, I think it's the first one that Security Weekly gets to record during the week. So we get first dibs on a lot of the news articles sometimes. And I know that Business Security Weekly and Enterprise Security Weekly, your friends, which I think you might even, I'm not sure if you'll be chatting with them this week, but we'll likely be talking about the Uber consequences, the recent outcome of that verdict. And I did want to touch on something real quick there because, yes, it's AppSec related because it was using a bug bounty to essentially do breach laundering, compromise laundering, and in a way to basically dissembling, which is the kind way of saying lie to the FTC about data exposure, which is fundamentally what I think the consequences of this court case were, rather than something like everyone, all CISOs are going to be personally liable for everything. So more of, I was kind of motivated just to focus on that part. So when we as the AppSec, InfoSec community are talking about articles or events, or at least trying to be precise or correct about what particular events say for the industry versus the broader what could possibly happen. So think of it maybe as an attempt at threat modeling. I'm not sure where I'm going with that, but I'm basically missing the opportunity to talk more and deeply because our friends on BSW, ESW will do that. So this was my way to cheat it in. Take it away, Mr. Kinsella. We can either bury that now or talk about it a little bit more.
I think to give it 30 seconds. So, I mean, I probably should have looked this up last week. In the U.S., it became, I want to say about 5-10 years ago, the C-level officials in the company, so CXO, CTO, that type, whoever is responsible for security actually has potential for legal consequences in the event of a breach. So this part of that is not new. I think this might be one of the first time that it's actually having, the teeth are there. I think everything else you said, I sort of agree with. I'm not really shocked by this. It's not the it's not the bug bounty part. That's where people are focusing on.
Right.
It's the fact that they were, trying to not trying to put this into polite phrases. We all know that there was. I think it is. I won't say we all know. It was known that at that period in the life of Uber that they had quite a few aggressive business practices. So with that, it does not come to me as a surprise that one of those business practices was to try and hide something of this scale from their customers, and that's why they are getting spanked. So, I think that the bug bounty part is fine. I wouldn't worry about. I would have no problem if I was in a large or small company with the C-level hat on, are paying for a bug bounty program, thinking it was going to come after me. So I think all the pieces around us are. People are getting worried. I don't think there's a good reason to be worried, and we'll probably forget about this within a month. But at the end of the day, if you try to do something like hide this type of thing from your customers, that's going to come back and get you. And I've been in companies where that's happened in the past, and it doesn't feel good on the inside. So it's just do the right thing, and hopefully you won't end up in a situation like this.
Indeed. Well said. So let's move on to other topics that are probably more AppSec solidly related. And this one is actually about Rust landing officially, I will say, into the Linux kernel. So there's an aspect here, though, I was kind of curious to get your thoughts on, John, because we've been talking about Rust was coming into the device drivers. So basically targeting a good attack surface that's rife with mistakes, that's notorious for being having problems with security problems, as well as actually being relatively self-contained, isolated, so that it makes itself a good place to have a first step to introduce Rust. So after a year and a half of, I think, Rust living within the Linux Next branch and over 170 contributors, there's finally this initial merge dropping into the mainline Linux kernel that half of the commits are pretty much just some Rust standard libraries for alloc, essentially being friendly to memory. And the rest of it is actually tweaking ancient, speaking of cuneiform, ancient makefiles and configuration and build scripts just to be able to make this work. So I'm not going to say I'm wrong. I'm going to say I'm sort of rethinking some of my thoughts. And when I say, oh, well, what if we refactor? What if we just rewrite some area of code from C, C++, some language into Rust, into Go? If it's going to take a year and a half and 170 people, that's an investment. I think it's a good investment. It sets us up on a right and a more secure path for the future. But it's not something you do over an hour listening to ASW, is it, John?
Yeah. At least you'd have to listen to at least a few weeks worth of ASW. Yeah, I'm just sort of flipping through the link you have for not the PR, for the merge notification on their mail list. Yeah, it's big, right? And there's a lot of stuff going on, but I think, as you were hinting, it's not accomplishing a ton. And that's, I get it. When you add something new, I mean, this is a lot of scaffolding. So you're adding something new into the, so for folks who are sort of, not up to speed with us here. So we've been talking about this rusting in the kernel for, as you said, a year. It takes a lot of these people to sort of go and improve the thoughts out and sort of figure out, is that the best way to do it, or how can we improve and simplify and things like that. At the end of the day, your first major commit on a project like this is going to be that, okay, let's get the scaffolding in place. Let's see how it actually works when we put that merge in. If it was me, I'm guessing they're going to be the same way. Let's let it live there for a release or two and see what goes bump in the night. And then we'll start actively really getting to the work going. What am I looking at? This is C. There was like some code that looks so weird, it's actually making me double take. Yeah, so it's if you want to see what a large PR looks, or excuse me, I'm still thinking GitHub terms. If you want to see what a large commit looks like in Linux code, this is sort of good to look at. And actually, from the point of view of people who are thinking about how do you add a new major technology to your project, this is a great thing to look at, right? Because that's sort of and maybe I'm guessing it's partially why you brought that in here, Mike, not just for the sake of saying, hey, they did it.
Right.
And that's super useful. I would want to make this useful, I would want to get out of this email, which goes on forever, and put this into GitHub or somewhere where I can actually, even if you, let's see, if we look tree, I know you can, on the Linux Git site, gitkernel.org, you can get a little bit of usability out of this from a UI UX point of view, but I'd probably want to look at this in either locally or on GitHub and actually get a better sense, at least in tools I'm used to day to day, of what the PR actually looks like. How did it modify and tweak things? You can see the highlighted changes here, but there's probably a better way to consume it.
Yeah, I think, and to be clear, I think this, as you put well, this is the infrastructure. You need to have this type of information in place so that you can then start to build the more fun device drivers. And it is nice to see that, yes, they have the infrastructure, the crates and bindings, so that you can have a minimum viable build here to once again steal fun business language. And there's also kernel documentation and samples. So there's documentation in here that's also useful. So great to see. We'll continue to follow along. And I'm also going to take this moment to say, love to see Rust, or Go for that matter, our memory-safe languages grow. But if we look at what the NSA and CISA and FBI are talking about, the top CVEs that have been exploited by Chinese state-sponsored actors, that list is remote command execution, RCE, RCE, RCE. And the other reason I had to include this, yes, path traversal lands there on the bottom. So there are still plenty of other attack classes to be training in secure coding. So Akira, if she's listening, just don't rely on just the second slide after just fix everything, write everything in Rust, because you're going to need a third slide about path traversal or RCEs and so on.
I'm backing up for 1 second to the previous story, and I'm going to combine, maybe not path traversals, but paths. So still looking at the merge source, they actually made Rust a top-level directory under the Linux kernel. And just for folks who aren't familiar with this, the other directories look things like architecture, block drivers, certificates, crypto drivers, file systems include. So they're very high-level kernel concepts, right? And then there's one for Rust. So that's interesting. I think what would be interesting to watch over, let's say, 2 years, maybe 3, is how does that actually start to permeate into the rest of the kernel? Do they always keep it separate? Or are they going to, I don't know if they have a plan for this, but is that going to sort of, once they get used to it, sort of go in and get its hands deeper in there? But to keep going, on your list of RCEs, which the NSA has said is being actively used, the one that caught my eye was on the web server for Hikvision's camera command injection. And this is sort of, it stood out for, I hate saying, I don't know what the reasons are, but it stood out for, well, obviously for reasons. And this is a list of things which are attacks from China state-sponsored organizations, and the Hikvision cameras are from China, which is why I'm giving it attention. And there's various degrees of people wondering how much actual coordination is going on among those type of things. And I'm sure I've got a Hikvision camera somewhere, and I'm probably pronouncing it wrong. So if I am, my apologies. I'm used to just seeing it written, but that was interesting. But the rest of them are the common things you all have heard us talking about on the show for the last, since 2019. Citrix, Buffalo, Atlassian, Zoho, Microsoft, F5, Log4j, Ding, Pulse Connect Secure, GitLab. So it's the common, but I guess it's interesting that they're going straight for the RCEs. If I had to try and have a takeaway from this, right? So they're not doing so much a more subtle attack where they get a small fingerprint or a small foothold and then start going from there. They're going straight for the good stuff.
Yeah,
and one last sorry, real quick on that is they're not just this list is a list for a reason, right? So they figured out that the level of success on these attacks is significant enough that they can use these time and time again.
Yeah, I think there's perhaps a path of least resistance because these just work so well, as you said. And the other story here, if you look at the CVE list of CVEs, 4 of them, are from 2022. The rest are 2021, 2020, 2019. So I think there is definitely a story about patching that falls into here, and why aren't systems patched? And we'll just leave that as an exercise to the listener to patch all of your systems by the end of the news segment, because it shouldn't take more than 30 minutes, of course.
Please hop in our Discord and tell us why your systems aren't patched. We'll be waiting.
Yeah. I don't think those are going to be a polite conversation, John. I'm worried. But speaking of reading code, let's see if I can nerd snipe you again with one of my other things that I do when I look at vulnerabilities and try and talk about. I also try to look at the patches. How do they get patched? And was it an interesting commit? Is there something we can learn from the commit? And actually, I think that's a bit of a callback to what Akira was saying too, that it's helpful that even if you are, let's say, a PHP developer or a Go developer or whatever your language, it doesn't hurt necessarily to read vulnerabilities in other languages if you're looking at the principles or how they're being fixed. Now, I think it's important, of course, to say if we're talking about input validation and talking about secure coding, you do need to be relevant to the tech stack that people are working with. But here is a vulnerability from friends at Oxeye, actually, the JavaScript VM2 package in NPM had an RCE that's a pretty nice write-up. And I was looking at the fix for it, which is literally a one-line fix that was related to error handling. Basically, because without that, an attacker could essentially pull down, could trigger a call stack, and read the call stack would reveal lots of sensitive information about the rest of the information outside of the sandbox. So basically breaking the intended purported isolation of VM2. So this is one of those things that's interesting to me because obviously, there's code reviews, there's things that are easy to miss just about a one line. So it's more of just not a mean-spirited, how could this happen? How did someone miss it? But more pointing out flaws happen. And when it's a one-line fix, that's awesome to be able to see that it's easier to roll out. But ouch, just that missing that one line has really gnarly consequences to date myself with using some language here. And it's just interesting how easy it is to miss things from a general code review, let alone a secure code review.
Yeah, maybe we need to change the topic or the title of this podcast or this episode to dating ourselves. Yeah, and I was thinking about this in the last segment where we were talking about how do you do code reviews, and this is, so we've been having conversations internally with as I mentor some folks and how they do code reviews, and where's that balance between becoming a blocker that's slowing everyone down and actually nitpicking every little change you possibly could get versus making a few comments and saying, oh, by the way, this needs to be renamed, and not slowing down the overall process of what's going on, because that's what some people worry about. Having the focus on a large PR to catch a single line missing like that, it's pretty tough, right? So then do you catch that in static analysis? How do you, I get if your unit tests are amazing, you're going to catch it. But that requires then, another thing with a lot of managers hate, which is, spending a lot of time on your unit tests. So it's the question I'm asking is what's the best way to go about in the real world actually catching this? And it's pretty tough.
It is. And I think I wanted to pull in this VM2. I had another article that was a supply chain attack on PHP using Composer that I think we're going to build towards an article you also had on supply chain. So real quickly, on the PHP article that I had about attack against Composer, it was pretty interesting what sorry, losing my train of thought here. What the technical part of the attack was basically mucking about with command line arguments and doing command line argument injection, which is pretty clever, pretty neat. And I learned at least a new Git command line argument that was basically end of arguments. A long flag, which is pretty interesting. And so I want to set that aside for a second, though, because the previous article was talking about VM2 had more than 4 million downloads per week. This article is talking about 2 billion software packages served every month. So, better than McDonald's. And it's interesting to see articles that are talking about number of downloads, the CVSS score, how many users are doing this. And I get the desire to put context around here, but if we're in the spirit of this is our episode about rhetorical questions or polling the opinions and ideas from listeners, what would be something more effective to help just give the sense that this is important? Because honestly, if you told me this serves 100 million, 1 billion, or 2 billion, all of those numbers in my mind just mean this sounds important. I should go fix it if it's in my environment. I don't necessarily need the seven significant digits or degrees of accuracy for this. So just a thought process there. But don't know if you want to talk about the PHP one or tie it into supply chain and SBOMs, which are still somewhat related at the moment.
So I didn't look super close at the PHP one. I did see it, and the problem, honestly, the part that caught my attention was packages because I hadn't heard of it. But yeah, it's. I don't want to say it, but I'm going to say it. I think things are going to get worse here before they get better. Just because this type of stuff it's so persnickety to catch this. And like sometimes we have it's a one-line change like in the previous example. Sometimes something like this, it's an upstream problem, which that is hard to fix. And then, okay, are you using that package? Are you using the update? Are you using the vulnerable code? And it becomes fairly difficult thing to really track down. And we've covered that a few times, so I will move on to the other one if I can find that tab. And this was a story, actually hat tip to Clint Gibler, mentioned it last week. And it's a blog post over on crashoverride.com. The SBOM frenzy is premature. And let's see, there was one sentence in here I liked, which I thought summed it up quite nicely. If I can scan really quickly, because I lost my highlight. They, being SBOMs, are not an effective attestation mechanism of what is being shipped between a producer and a consumer. The use case being pushed by the Security Open Source Act. So the first half of that is SBOMs say, in his opinion, are useful for software producers to do the right thing and not knowingly ship code with known vulnerable dependencies, but are more useful for consumers to check the code than they are using for known vulnerable dependencies. So what they're saying there is these things which everyone's going to save the world. It really just says, hey, is this library included or not? And it's funny, I didn't walk into this quite meaning to set myself up so nicely, but as they're saying it's just because something is being shipped with it doesn't mean is it actually is it safe? Is that part being used? If it is not, if it's it's a very high level concept. It's better than what we had, but still there's a long way to go. And there's I see the phrase dependency hell highlighted further down in the article, which I can agree with, because this is still, even if you know there's a problem with even if you identify a problem through the SBOM, actually fixing it isn't always as easy as it seems. So I don't know. I think, as we've heard about, we've talked about this over the year. We've heard about the announcement out of the White House in the U.S. We've seen people start to pay more attention to this. This year, but I think people are starting to realize that they're not going to hit the deadlines that a lot of people are not going to hit the deadlines which the White House has asked for on these documents. And then the second part is, even if you do, it's helping, but is what else can we do? How much further can we go? So that's sort of where I am on this whole thing in general, I think.
Yeah, and I think especially talking about the timelines, that's where small SMBs, medium, and smaller. Basically, if you're not the Googles, Apples, Metas out there, you're going to be struggling with being able to generate SBOMs. I do like the principles behind SBOMs and making sure that we have that we're defining what it addresses. It's not fixing every single thing. We're not going to be magically secure because SBOMs exist. But if we can improve the compiler chains and tool sets to produce SBOM materials automatically, I think that's going to help a lot of the developer space here, so that when we have either harder things to inspect, like statically compiled blobs, does this have a version of OpenSSL that we care about? Or do we just know that this does have this particular Java logging library that I won't name because we've already done that once this month? That's at least helpful. So it can be a positive indicator. So that's much easier to just say, do I have this vulnerable library with me is not necessarily dispositive, because SBOMs might be incomplete, they might be inaccurate, they might not have be expressing the very specific version that you want to know about. But I think it's a trajectory much like dropping dropping Rust into the Linux kernel. I think is a positive trajectory. So I shall remain positive and optimistic for SBOMs, while acknowledging that it's one tool among many that we need to improve the ecosystem of applications.
Yeah,
security.
and I'm not just trying to talk crap about it in general or specifically, but it's more sort of, I want to make sure people are aware that this is just a piece of the bigger picture, and going to a lot of trouble to create an SBOM, because that's what it is right now. It takes a decent amount of trouble still, at least in some languages, it's not going to solve everything for you. So it's a good experiment, it's a good process, you're going to learn, you will be better for it, but you're not in the clear yet.
All right, well, John, we're friends, and I want to give you the chance to talk crap about something. So what about Intel's Alder Lake BIOS source code? Is there something, are we keeping you constrained here, restrained? What's your opinion?
I haven't gone through all the source code yet, so and this is if I happen to have a copy, because it appears and disappears in different places. But hey, let's talk about it. If I can find the tab, not that I need the tab, but hey, yeah. The BIOS source code for Intel's Alder Lake chipset was quote unquote reportedly leaked online last week. As of, that would be yesterday, Intel has confirmed the leak is legitimate. And apparently security researchers are analyzing the code for vulnerabilities. So speaking of that, one of the things I found in said source code is there's at least one private key. And that seems like low-hanging fruit. So I'm actually, hey, I see two private keys. So there's at least something worth looking around in here. It's 14 gigabytes. Did I get that right?
It's more than a weekend project.
7 gigabytes. There's a lot of binaries in it. There's a lot of weird stuff, at least to me, and I think it probably makes perfect sense to someone who's a chip designer. But I saw MATLAB files, and maybe they're being the magic numbers being misread on them. But so there's a lot of stuff in here for folks who want to sort of go and, at least look at how this stuff is put together. And this is obviously for research purposes, and you still might want to contact a lawyer before downloading a copy. But there's a good chunk of stuff in there. It's interesting. You need to, it's from the point of view, actually, let's bring it back to the last segment again, talking about this code review stuff. Mm-hmm. So I think, and that's sat okay in my mind, but I've mentioned it a few times, so it's on my mind. I think one of the things you need to do before being able to do a code review is you need to be able to read code. And read code quickly. If you're dumped into a project you've never seen before, go hop on something random on GitHub maybe and go look around and actually figure out how something's put together. Or the reason I'm bringing it up in this case is when you look through a lot of the tree for this, you'll finally find some C files. But a lot of those files just have either include definitions in them or really basic if logic, and it looks like nothing's going on until you realize there's this IO writer 8 function, which is actually being used to do the calls into the rest of the system. So it takes a while just to look at these things and sort of figure out what's going on. And so from that point of view, it's also sort of a good little project to get a sense for how do you do this stuff with some level of efficiency and understanding. And you already heard me comment once today, on the kernel thing, is that C? I haven't coded C in what? And this was sort of weird looking code. But that's the thing, right? It's okay, if I'm looking at this, was that C or a makefile or a Perl, right? Because they can all be sort of really sort of disgusting looking. And what are you looking at in that thing? And so there is educational value in these and looking around them.
Speaking of educational values, excellent setup for that. I did throw some articles in here talking about prototype pollution. We mentioned a vulnerability for that and didn't go into details, but I thought I'd throw in an article, or 2 articles actually, talking about JavaScript, the proto property, and how that can be used and abused within the JavaScript environment. It's still one of those areas that I see these a lot when we're running SCA tools, and that there's always this library, this other JavaScript library, blah, 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 has a vulnerability to fix for prototype pollution. So, developers, apply this version bump, apply this patch. but I've seen it rarely. This is an observational bias probably, but I see it less often within bug bounties or within exploits. So it's just one of those things that I think is always interesting about here are flaws we're finding that need to be fixed versus flaws that are being exploited, which just informs things like prioritization. Is this something that has to be fixed within a day versus a week versus a month, something like that. The other educational document I threw in here was the CloudSecDocs. These are not new necessarily, and it's also from the CloudSecList site, cloudseclist.com, which is another resource, much like TLDRsec that you mentioned, John, that we always check for what happened in the news this week that we should talk about. But I threw that together because I just wanted to add some additional educational items in here just so that we are not just too overly focused on vulnerabilities. So I don't know if there's anything that appeals to you in those, or we can switch to another article about careers and interviewing.
I hadn't seen this before, I don't think. It feels like, I've been clicking around the last half hour or so. It feels like Cliff Notes for modern security. At least I'm looking under container security stuff since I sort of know a little bit about that. And it's a nice mixture, but I think what I could probably use is some links out. I don't think I saw those. So it's a good overview and good. I'm probably missing because that would make sense. But it's definitely, these are short pages that are very technical. There's some examples in there like going out somewhere else, but so there's a bunch of good info in there, but and it might be because I have, again, a little familiarity with this. It feels easily consumable. A little bit of graphics, a little bit of sort of tables. And I don't know. I'd be curious. I don't know. Well, you were looking through it. What did this seem? How did it come across to you besides just being concise? Was it something you turn to on a day-to-day basis, or?
Yeah, it's one of those things, probably not a day-to-day basis, but the idea of here is a topic, whether it's AWS, GCP, containers, et cetera, and what are some important things I need to know, and what are some links, what are some resources that I can do a deeper dive in. So I think it appeals to different levels of familiarity with these topics, and we're talking about the CloudSecDocs site. One of the things that did appeal to me too is they've got a tab, Culture and Engineering, which I appreciated because it's a bunch of links out to Netflix, unsurprisingly, but it's talking about, engineering decisions, how to think about engineering processes, which is often, I don't see those in security-focused types of references. And I like the idea here that, security isn't necessarily, and perhaps maybe shouldn't even be dictating what the designs look like. Security should be helping to guide, influencing these decisions, but these are ways to think about the culture of how we're building software. What does it mean to, just what are we trying to do? And are we protecting data for our users? Are we protecting users? And those are the aspects that appealed to me. It has a cheat sheets section as well, but I will admit that I like the OWASP cheat sheets a lot more. They feel a bit more robust, and the more of the daily references than the cheat sheets here. But that's just my personal bias and what I'm looking for in cheat sheets.
Yeah, I just got into the cheat sheet section, and quite honestly, some of these things I don't keep in my head, like how do you initialize a map in Go, like I'll use it once a month, and if I'm not copying it from somewhere else in the code, I just Google it. But yeah, I think I'm guessing that's still to be built out a little more. It has potential, but it seems like they went from talking about security to just talking about cheat sheets for programming languages. So.
Yeah, and I think it's all within, it's all managed within a GitHub repo. So I'm sure, pull requests welcome. So,
yes.
There's a lot of things to contribute talking about community. Also talking about perhaps community and interviewing. One of my technical interviewing questions would be how to map variables within Go, John. So, this is a very important topic. I say quite facetiously. There is an older article that I pulled out. This is from 2020, but I thought it was interesting and helpful because we've been talking about, security education at the university level. We were talking about secure coding just now with Akira. And here is, folks who either have graduated, they're trying to get their first job, or junior to senior folks doing technical interviews. And what I really appreciate about this article is that it's talking about technical interviews, and yet it doesn't have any specific questions about, Go maps or tech stacks or anything like that. It's very much about other skills or the interviewing process and what it's like to set up an effective interviewing process. So I thought this was a really good way to, a good resource to read through for those of you who are hiring managers or who are doing the, sitting on interview panels.
Mm-hmm. A little more pointed on your comments at the bottom. Their last, I think it's her, Lori.
Yeah.
Last paragraph is, but you didn't include algorithms.
No binary search trees.
And that tickled me. The one thing I didn't see in here, which I'd want to see, which I would like to see, is standardized questions. So if you're interviewing, if you're just big enough that you've got maybe 2 or 3 people interviewing the same developer, or, each of the developers which you're considering, each of the candidates which you're considering. As you mature, we talk about maturity in AppSec and things like that. Maturity of your interview process, I would like to see people having the same questions asked to each person. So then you can, throw those into a matrix and sort of compare and contrast evenly what their responses were. And then the other thing, just being 2022, they talk a little bit about nerves, but I'd want to also sort of consider how do you try to minimize for inherent biases. So, but other than that, I think it's a great start. It's a great thing to think about. How do you, just looking at it from a high level, it's a great thing, right? How do you interview someone to be a developer? And like we're making jokes. People have tried the algorithms thing. People have tried different angles, but yeah. I'm still a huge fan of take-home problems. As they're saying in this article, design whatever that problem is around what they're going to be doing on the job. Don't just make it arbitrary. The other one I'm seeing recently, there's a few startups, or probably bigger than startup now, that are doing basically outsourced online coding interviews. So you'll end up in a video share with some person, either locally or possibly around the world. And they're like going, hey, here's this data we want you to manipulate in such and such a way, and you've got an ID, and you have to go and do the typey. So I think I would prefer that to a whiteboard, but still I'm a big fan of the just let someone work on it at home, because that's what you're going to be doing in most of us in our jobs, right? So, but yeah, good to think about and cover and keep on people's minds.
Yeah, and I think I rarely in developer interviews is there a secure coding or like a security review section, and I'm not necessarily saying that's necessary because you're also time constrained. But there's also an aspect of perhaps just talk about like a code review aspect that perhaps should focus on the skills or the approach to code review that Akira mentioned. Are you being constructive? Are you being just brief, relatively neutral? Or is this the worst code I've ever seen? And even Perl can look better than this, which perhaps is not the most friendly approach. But that's my final thoughts for this episode. John, I'm going to leave it to you. Have we given you any additional phrases for your T-shirt collection, or is there any additional messages you'd like to end on with our listeners?
Nothing new on the T-shirt collection yet. We've got our eyes and ears open. I believe you had a link in here for hacking Google. Yeah. That looks interesting. So I'm going to have to go back and look at that later. A bunch of short little videos. And then I had one just for people to think about, which I wish there was more meat behind here, which is why we're probably not talking about it. But Moody's, the insurance company, updated, or they put out a report talking about I think they call it their cyber heat map. But so Moody's has $80 trillion worth of value under $80 trillion worth of customer goods under in being insured. That word. Of that, 22 trillion they believe has high or very high cyber risk exposure. It's a large number. And like I said, it sounds like there's more behind it, but it's behind a paywall. But the reason I brought it up is just for people to think about, the insurance companies it's great that they're actually starting to think about this and put some actual monetary calculation behind what's going on here. But then to bring it back to our local level is not that I'm expecting any of us to do, because it's really hard if you try to, how do you calculate risk or value it, even of a vulnerability on an asset in your organization, not alone a vulnerability in code. But, that's a goal, right? How can you improve? And, as we do all these different things, we talk about not insurance, interviewing and the SBOMs and all these type of things also is like, you've got this problem. And Mike, you were talking about prioritization a few minutes ago. This is another way to think about it. Can we put some sort of a value, a number on what we're doing, and then allow us to make more informed decisions?
That's perfect. Thank you, John. I want to thank all of our listeners as well. Thank you for joining us. Please subscribe, hit that like button, check out the show notes. And, speaking of 80 trillion, we're not quite there with our listeners. So please do share, and let's see if we can hit 80 trillion listeners by the end of the year. And with that, I will see you next week on Application Security Weekly.